Hello there. My name is the Tacos. This is Dirtbag History. We got a special one today. I have a man on. He is a nuclear astrophysicist. Say that 3 times fast. His name is Anuj Parikh. He used to be a professor in Barcelona. He used to teach nuclear astrophysics. He's an extremely smart guy. He's an actor. You could check him out. He's a good egg. Good egg club. Yeah, we had a great conversation. He blew my fucking brain away. I don't know what I don't even know where to begin. Like, literally, we just talked like maybe an hour ago, and my brain is still spinning. So, if you like astrophysics, you like space, you like UFOs, you like, I don't know, fucking stars and black holes and dark matter and antimatter and fucking dark energy, this is the place to be. This is the place to be, because this guy's screwed in and he fucking gets it. Do me a favor. Like and subscribe. If you're listening to us on Apple Podcasts or Spotify, rate and review it there. And the best possible thing you could do is share it. So do me a favor and share it. Of course, we got the Team House. Check that out. That's a podcast that I produce. Fun time. Check it out on YouTube and everywhere else you get your podcasts. And last but not least, we're sponsored today by Manscaped. So go to manscaped.com and use the promo code TEEN20, all one word, TEEN20. You get 20% off and you get free delivery. What's Manscaped? Manscaped is basically you get a nice package for your package. Basically, you shave your balls. And they give you like a ball deodorant and like some other stuff, which is awesome. Check it out, manscaped.com. Promo code at checkout is TEAM20, TEAM 20, all one word, 20% off and free delivery. So now, without further ado, I give you my guy, actor and nuclear astrophysicist, Anuj Parikh. Thanks again, Anuj, and enjoy the show. Bye. But I try my best.
No, I trust you. I'm looking forward to this.
Me too, man. Me too. Yeah, because listen, astrophysics and I guess just space for like, I'm a layman too. I don't know what the fuck I'm talking about most of the time. But it's so crazy to me because I'm gonna say I'm an atheist probably. Like, I would like to hope something's out there maybe if we die, but probably not. So like when I hear about and read about astrophysics, it's like the closest thing I feel like we'll ever get to like understanding the trivial, like outside of the trivial bullshit that we deal with here day to day. You know what I mean?
Yeah, absolutely. I mean, that's one of the reasons I started, studying this kind of thing. But I mean, just because, I mean, there's no reason that something can't be out there that, might be godlike. But
Sure.
there's no
Yeah.
reason, it may not correspond to what we want it to be.
Right. Yeah.
But that's why it's interesting.
Yeah. It's not going to be the same shit my priest talks about. You know?
Yeah.
So I just want like give yourself a little introduction. You used to be a professor of astrophysics, right? In Barcelona.
Yeah, that's right. So I used to be a professor of physics in Barcelona. Um, I mean, my field is actually, I specialize in nuclear astrophysics, which is
All right.
which is
Humble brag, but okay, sure.
which is really looking in detail at the nuclear physics involved in explosions, in particular thermonuclear explosions. So these things that occur on compact objects like neutron stars and white dwarfs. And I'm just throwing these words out there, but I mean the point is that astrophysics is so big that when the further you go, as you might expect, in the field, the more you learn, the more specialized you get, and that's how you make a living.
Sure. So it's better to be specialized in a certain, I guess, would you call it a vocation? I mean, I don't even know what to call it, right? Like, I mean, would it be better like if I'm just some astrophysics guy or if I'm a nuclear astrophysics guy? I guess it's better to like really focus in on one aspect of it.
You're forced to. I mean, when you write your thesis, I mean, it has to be on a very specific specific aspect
Yeah,
of the world, because I mean there's so much out there, and that if you really want to make progress, you really gotta zone in, kind of razor tight on
sure.
one thing, and then you become the world expert because there are only, a dozen other people that have done that. So
That's yeah. I mean, listen, it makes sense though. If you really are cutthroat, like you could probably become the fucking expert. You write something that people dig, you probably win a fucking Nobel or whatever.
yeah, sure.
So what made you get out of it? Because you're out of it, right? You're not teaching anymore anyway.
It's yeah. So I mean I was basically offered tenure at my university, and then I started, yeah,
That's
right.
like that's pay dirt right there.
Yeah, exactly. So then I started talking to a bunch of my colleagues about what that actually entailed, what they actually did with their lives, as a tenured professor. And unfortunately, it just turned out that a lot of them, too many of them, spent most of their times, doing stuff like writing grants, dealing with students, going to committee meetings, things in academia that are almost kind of stereotypically academic.
Sure.
Basically everything other than doing what they loved, doing what they got into the field in the first place for.
And I asked you, like, in terms of tenure, you have to continuously like publish and stuff like that. Like, you have to keep like a certain level of like production in terms of like articles or papers or whatever like that to like keep your tenure track or keep your like I don't know what. I don't know.
Right.
If you
So,
get
so
tenure, you can just cruise, no?
you, in general, yes. I mean, but at least at my university, the responsibilities differ depending on if you don't really publish. If you don't publish, you get more teaching, for example,
Okay.
or you get the worst committee meetings, or
What do they
things.
talk about in committee meetings?
Just horrible. Just university policy
Oh
and
my god.
not physics, not
Oh my
physics.
god, that's brutal.
Yeah. So basically, you become a manager the more senior you get when you've never been trained, as a physicist to be a manager. It's not, if I
Sure.
wanted to be a manager, I'd go do my MBA.
Or
There are
just
lots
go to
of people,
Starbucks and become a manager of Starbucks.
exactly. I mean, there are lots of people that love being managers. They
Sure.
should be, they should be going to those meetings.
That's so interesting. Yeah, because I'm assuming like somebody like you want to just do your research and you
Yeah.
know do your
Yeah.
work and that's it. You don't want to have to fucking deal with like, oh my god, this professor fucking sexually harassed a student. Like, what the
Exactly.
fuck? We got to deal with this asshole now. Like all that kind of shit.
That's it. That's it.
Oh yeah, that's brutal.
I mean, it's not that I want to close myself off and be kind of, in my own little world, apart from all these kind of big issues, but it's just that in terms of, my day-to-day work, um, I just wanted to be a physicist.
I mean, yeah, it's fair enough. You know what I mean? Even like I could see like I guess for me, I could see like more teaching at least being fun and stuff, rather than like the internal politics of a certain university. It's like, oh fuck off, dude. This is what I got my
Absolutely.
PhD for. Are you kidding
Yeah.
me?
No, absolutely. So, I mean, the teaching aspect, I mean, depending on how much teaching you have, but teaching is fun because unless you can, effectively teach students or anybody about something, then you don't really know what you're talking about
Yeah,
because the students in particular, they're sharp. They'll catch you when it's clear you don't know what you're talking about, and then
yeah.
you've lost them forever,
I'm
right?
sure like a nuclear astrophysics class, like it's not fucking freshman year math students who are like hungover and shit. You know what I mean? Like these kids are
Yeah, yeah,
sharp.
yeah. Exactly. They're there because they want to be there, not because, they're trying to do something else.
Yeah. Yeah. So I could totally understand why you kind of moved away from that whole like professor life, like inside, like doing that whole rigmarole. So, so you wanted to become an actor? I feel like that's another like not feudal, but it's extremely difficult.
Yeah, I'm learning.
Oh, you're figuring that out. Okay.
Well,
Yeah.
I'm figuring it out because acting is one thing that nobody ever tells you that you can't do or that you can do. I mean, so when I left physics, I came here to the city, and I did something that a scientist would do. I looked for acting classes, I looked for conservatory programs, and that's
Yeah.
that's that's what a scientist would do. I
Right.
checked them all out,
Yeah.
I signed up for one, and at one of the first classes, I went to my teacher and I said, straight up, I mean, if I would like to know if you think I can do this, because if and I'll trust you, because if you think I can't, great, I'll do something else. And of
Sure.
course, an acting teacher would always say, that's not the right question to ask. I mean, you really want to, start exploring and, breaking things down, trying to find yourself because there's only one of you as an actor, and that's what you're bringing to the table. You're
Mm-hmm.
not bringing like all this knowledge that you've gained.
Right. It sounds like your acting teacher wanted you to keep taking acting classes and get paid.
That, that's that's another thing actors do. They teach classes.
Listen, like I'm not an actor, but I made a movie, like a feature, like I directed it and wrote and stuff. It was out on Amazon Prime and now it's on YouTube.
Cool.
So I kind of understand like the process and not the acting process at all, but like making the movie and producing a movie. I mean, listen, it's a great creative endeavor. It's super fun. I told my story how I wanted to do it and stuff like that, and it's awesome. And I'm happy and I'm proud of the product.
Right.
But the other side of it is like, I guess the commerce side or like the networking kind of side is absolutely fucking brutal. It doesn't even matter if you're talented, really, because I
Yeah.
remember like auditioning people, a lot of like not SAG actors who are really fucking talented actors killing auditions. And I'm like,
Yeah.
fucking, you got to keep grinding. And even if you're great, you still got to get lucky.
Yeah.
So it's like, it could be super frustrating. And I have a couple of friends who from the movie and stuff who tell me like, half 80% of the shit they go and read for is absolutely atrocious. First off, it's some jerk off's fucking student film or whatever. It's like some terrible short that no one's ever going to see. And they have to like act like they are into the material. Like, so it's tough. It's not an easy gig for sure.
Yeah. Yeah. So I mean, everything you're saying, I can confirm
Yeah. We're on the
from my
same
from
page
my own experience because I mean, you're right. I mean, the luck. I mean, okay, in most professions, to make it, you need to be kind of lucky.
without
But
a
as an actor in particular, especially here in the city, there's so many actors. There's so many. I mean,
yeah.
and they're all kind of competing for the same, few good gigs, and there are lots of kind of things that are not so great that
Sure.
they go try to do anyway. But you're right, you have to.
You got to put together a reel, man. You got
Yeah,
to
man,
show what you could do.
that's right.
That's why, like, yeah, if you're gonna really keep going for it, make your own shit, make your own shorts, like, do your thing and showcase what you could do
Yeah,
because it's tough. I mean, so good luck, bro.
yeah,
I'm like a cynical, browbeaten fucking animal. Like you know what I mean? Like I'm so miserable. I'm so bitter because I paid for the movie too. You know what I mean? So like,
yeah,
I wasn't expecting it to be bought at Sundance for $1 million, and I'm
yeah.
like, the next Wonder Kid, and I'm doing the next Marvel movie. That's not what I
Right.
expected. But I kind of wanted to show that, like, hey, I could do this. I've never made a movie before, never made a short either, and we just rocked and roll and did a pretty good job. Like, it's not the best movie ever,
Right.
but it's passable. I think. I fucking hate every minute of it if I watch it now because I've seen it like 1,000 times. But
Right.
I think it's like pacing wise and like the structure that you need to make a movie. It's passable, and I'm proud of it.
Cool.
But I didn't get an agent. I didn't get any of that shit. You know what I mean? Like. So it's tough. It's definitely uphill battle, and it helps if like you have an uncle who's in the business or something. You know what I mean? Like that, a little bit of nepotism is always the way to go.
Yeah. Yes.
Sprinkled in there just to get your foot in the door. But yeah, so astrophysics.
Yeah. Yeah.
The one question I got because you ever watch Lex Friedman's podcast? Because he has a lot of astrophysicists.
No, I've never seen it.
He's a relatively bright guy. He's a MIT like researcher who does like AI stuff. So he has like a ton of like intellectual people on. And he had the guy Avi Loeb from Harvard,
Yeah.
the Omuamua guy.
Yeah.
And he always asked like these astrophysicists or whoever what they think about like like aliens and all that. But the first thing is like that I've gotten like from almost all of them who I've been on his show is they're all like pretty fucking negative, saying like, yeah, I think we can maybe get to Mars and stuff, or we can really go outside our solar system in like hundreds of years or so, whatever the case is. It's like, but I don't think humanity is really gonna make it a couple hundred years because we're so like destructive.
Right.
Is that like a common thread amongst all people in this field?
No, I wouldn't say that. I mean, I don't know if that's really a question that you can only ask astrophysicists because it really. I mean, you could ask a political scientist and they'll probably give you a better answer than an
I mean, you
astrophysicist.
ask me, I never even graduated college, and I think, yeah, we're fucked. Like, we're not gonna make it, you know?
Right. I mean, what? Yeah.
Good question.
What do I think? It's. there is this kind of capability of that humans like to destroy each other, but we're not going to destroy all of us. I mean,
Sure.
there are going to be people left. Um, and these people, they may not be the right people that can foster, this kind of utopian society
Right.
of touchy-feely love and everything, all that. But um, you'd think that if it happened once, people would eventually learn their lesson. That's, of course, rarely true.
Sure. Yeah. Yeah. Yeah.
But yeah, I don't know if I would say, we're not going to make it past a few centuries. That seems unreasonably cynical to me. I don't have any special knowledge in terms of, the political agendas of different
If
countries.
you
But
had to place a bet,
yeah,
200, the year 2300,
yeah,
is humankind still on Earth?
yeah, yeah,
It is. Okay.
yeah. I'd put a big bet on that if you were offering money.
Okay. So you're positive. You're a positive nuclear astrophysicist. Congratulations.
I would say relatively positive, I guess, in relation to these other people.
They were very doom and gloom, bro.
What were they saying? I mean, I guess
Bobby
I need to
Loeb is
listen
like,
to
we're
it.
fucked. Like, I don't even think we're gonna make it like 150, 200 years. Like, people go watch the Lex Friedman pod.
Right.
It's hilarious. I'm like, holy shit, bro. And then they had another girl, a girl who was, she was some kind of like planetary. I don't know what she was. She was a fucking smart cookie. And she was like, too, like, yeah, I don't know. I don't think so. I mean, if I had a bet, whatever, like kind of similar to what I asked you, like, and it was just a two astrophysicists. I was like, wow. Like, what do they know that we don't know? Like, sure, yeah, we're fucking miserable and we like killing each other for some reason. But for us to be totally wiped out, like off the face of the earth, it's kind of fucking crazy.
Yeah, but I mean, okay, humans haven't been around for all that long. I mean, the sun is like 4.5 billion years old. Our planet is, somewhat less than that. But humans, as we know them, have been around for what, 1 million years? It's not a long time.
No, yeah.
So I mean, a lot of things can come and go in that time.
It's interesting too, because I read somewhere like even like fossils and stuff, like we don't even know how far back, like whether there was like before, even before the dinosaurs and stuff like that, just because like the earth changes so much that
Yeah,
in that time it's like no way to know.
exactly. Right.
All right. All right. So I
So
like
kind
the
of
fact that you're positive, more positive than the rest of them.
that's I mean, that's good to hear. Maybe, people know things I don't. I don't think it could be that big, but what do I know?
Sure. So Avi Loeb, we'll get into him. Like he's, big wig in Harvard, right? He wrote the book about the space object that came streaking through our solar system in like 2017, I want to say. And it was
Yeah,
acting weird, right? It wasn't acting like a steroid, an asteroid or a comet.
right.
His hypothesis was that it was like a piece of like space junk that came from outside of our atmosphere. Is he full of shit? Yes or no?
Um,
On
I,
attack. I'm just kidding.
no,
Yeah.
no, I won't answer that as a yes or no. But okay, so I mean, this is kind of an exciting object because it's interstellar, right? I mean, just based on observations over, I think it was like 3 months or something, it was, and its trajectory, you can tell that it's not, bound to the sun, and that it came from somewhere outside the solar system, and it's going back there now. I think it's somewhere beyond Neptune right now. So that's interesting. But I mean, what's interesting is that 2 years later, I think it was in 2019, there was this other object that was also interstellar. Um, yeah, so I mean that's two interstellar objects within a couple of years. That's exciting. Why is that? Probably because we're looking for them in more detail.
Sure.
We have better instruments that can see these things. Um, but I don't know. I mean, all these things about whether it's a piece of space junk or some sort of possibly a ship or something. The thing is, our observations were really just it's a point source to us. I mean, we don't really know its shape, or I mean, we don't really know uh, we definitely don't know where it came from. Um, because in our objects, it just looks like one pixel. And so we can look at the light coming from that pixel and how that varies over, 3 months. And from that, you can say, well, if it's bright now and then it's not bright, it's bright and it's not bright, well, that means that maybe it's tumbling and
Mm-hmm.
that there's a bright spot that we can see that then goes away and then it comes back to us. Okay, maybe that's true. But I mean, we don't know the size and the shape, we don't know how bright it is. It's really tricky to say anything. I know that there was this nice picture that, well, it was an
Yeah.
artist's impression that circulated where it looked like a cigar or something.
Yeah, and then
But
there was another one where it was like it's a disc, and like all the UFO
exactly.
maniacs were like, oh, it's a disc. Like, oh my
Right.
god.
Right. And that's because you have kind of this just this one knob. You're seeing this light curve from it. You're seeing how the light coming from it changes with time, and then you can make all sorts of crazy inferences. But maybe it's a flashlight turning on and off. I mean, we don't really know.
Sure. Yeah.
Make all sorts of reasonable kind of interpretations, but who knows? It was examined by radio telescopes just because of all this furor coming off the observation, and as we know, nothing was heard from it.
Yeah. So what do you think, dude?
Well, I mean, maybe we need better instruments. Maybe something was coming out of it, and we just can't
We
we
don't have
can't
the
see it.
technology to pick it up, or
Yeah, that I mean, that could be. There's another kind of interesting thing about the object was that there was this kind of acceleration that was picked up of the
that's
object.
what got people crazy. It wasn't
Yeah,
just
right.
getting faster.
Right, exactly. And nothing, no. And so the idea that initially comes up is that maybe the sun's heating it up, and then some compounds in there are outgassing, and so that's turning into something like it's like blowing.
Yeah, it's propulsion. It's a propulsion mechanism,
Exactly,
right? Like it's just pushing it.
exactly. But nothing was detected, right? When nothing was detected by whatever instruments we have, so then people started thinking, well, maybe it's something we can't detect, which is the obvious way to go. But these are all just ideas. Who
Yeah.
knows? Who knows? I think that all of this speculation, all of these things coming in are great because it fuels the public's understanding of or the public's curiosity for what these things could be, and that puts more money into trying to understand all the things out there because there's so much crazy stuff out there
I
that
know, man. It's just I started like getting into it. I'm obviously a fucking ape. So like sometimes it gets too dense for me, and it's insane the amount of shit that's like going on out there. And just like so that's why I really appreciate guys like you and women like you, women like, astrophysicists who spend their time in their life, and they're smart people that like do this and research this shit. I think it's important.
yeah, I mean, I think that this kind of thing can help to bring us all together because I mean, anything extra human can bring humans, you know, just it can arouse our curiosity in a way that things that other humans do maybe doesn't.
Yeah, 100%. I mean, I can't. Yeah, I totally, completely agree with you. So it's not a UFO. It's not a space junk or like a big space hauler. Like they put all their fucking garbage in and they're just shooting it our way.
um, Listen, I see nothing that says that it's not, and I see nothing that says that it is. I mean, I like to keep things simple,
Sure. No,
I
I can
guess,
respect that.
just because then you don't have to worry about it.
Okay.
And for me, the simplest idea is that it's just some sort of piece of rock that's been moving around.
So what about aliens? Are they living among us? Yes or no? These are yes or no questions. Don't.
Uh, again, I don't know. I guess I would say no because I haven't met any
Sure.
that
Me
that
neither.
confess that confess to be aliens.
Yeah.
I know lots of strange people though, so it's
Right.
I mean, what do I know where they came
Well,
from?
yeah, you're an actor in New York City, bro. Like you're
That's
gonna know a lot of strange fucking people.
well, just ride the subway.
Yeah, there you go. So, like, what do you think about Bob Lazar and his whole fucking story? Full of shit.
I haven't followed any of that too.
Okay, so Bob Lazar is like the super, like he started talking about this like years ago in the 80s.
Hmm.
He worked on Area 51 as a contractor, supposedly. He's obviously a very smart guy. He built like a rocket car. Like he knows what he's doing in terms of like science and shit. He said he went to MIT and another college, no records of him going there. He says like it's a fucking whole conspiracy. They're trying to shut him up and like discredit him.
Right.
He said he was a contract and he saw like a bunch of different spacecrafts on Area 51. And he said he was working on some kind of like the propulsion system was totally different. It wasn't like jet engines and stuff like that, like how we see where there's a trail coming out of the back, and like how the comet, you know what I mean, like that kind of understanding as we know it. And then I think you know why it blew up a little bit, because obviously Joe Rogan had him on, and Joe Rogan thinks there's fucking aliens everywhere.
Right.
And we started getting like the DoD started releasing these videos of like the Tic Tac objects like going around with the F-18s and stuff, and like doing crazy shit that are outside of the laws of physics and stuff like that.
Yeah, right.
So are there aliens?
Anywhere?
We'll get to that. We're
Okay.
in on Earth.
On
Living
Earth?
on Earth.
Again, I haven't seen any. So if it's a yes or no question, I would say no.
What do you think about like all these DoD videos and stuff with like these weird? They changed the name from UFO to something else.
Yeah, you're right. Yeah, the DoD has a lot of money going to it, so it's
Right.
I mean I'm not so I and a lot of that money goes towards developing things. I mean they have obviously employ a huge number of incredibly intelligent people. They have a lot of resources, things that the average person doesn't know about, just in terms of metals or great conductors. I mean they have access to levels of these things that normal people don't. So it wouldn't surprise me that they can create things that we are unaware of
Mhm.
yet, because eventually those things end up being, used to create, all sorts of things that we use, like mobile phones, all these things.
Right.
They arise from well, ostensibly military-esque applications.
Mm-hmm.
Um,
Yeah, that's what a buddy of mine, who's like a national security reporter, he said is like most likely what it is just like we're testing shit on our own people, like we're testing stuff on our guys right off the coast or whatever to see how they react and shit like that. That's what he's guessing. He doesn't think it's fucking aliens that are like going through space time. You know what I mean? Like
yeah, right.
he doesn't think it's like some sci-fi movie. I mean, it would be fucking crazy if that was the case, but again, it's too these videos come out in the last 20 years or so. Like we have HD cameras.
Yeah,
Why can't we get a fucking HD video of these things if it's like for real?
yeah, yeah. I would agree with you.
So they are here. Is what you're saying.
No, I'm not saying that.
In the whole universe. What about the universe?
Yeah, sure. I mean, the universe is a big place. I mean, the galaxy has what, like 100 million stars ish. So 100 billion stars ish. So
Just that number,
yeah,
the galaxy that we live in, right? The Milky
yeah,
Way, is that it?
exactly. Yeah,
Right. Has 100 billion stars.
yeah,
The sun
ish.
is one star, right?
Correct.
All right.
Yeah.
Let me check my math. Okay, yeah.
And
That's fucking crazy.
yeah, so you put planets around these guys. I mean, there are so many things that can develop that again, and again, our concept of life is, based on well, no, the examples on Earth,
Sure.
which are just, a small number of things that could develop given, the varied circumstances that can develop. I mean, you put just a land of just water, just a water planet, and we might have some sense of what could develop,
Mm-hmm.
but you give that, millions of years to evolve on just a water planet, you'll get some crazy things that we would never expect.
Another crazy thing that I don't think people really grasp because they're all fucking busy with Instagram and all that bullshit is like how light years work.
Hmm.
It's fucking crazy. If you sit down for like 2 minutes and actually think about it as like a normal
Yeah,
person,
yeah,
I don't know how it doesn't blow people's fucking brains out. And this is
yeah.
like simple shit. Like this isn't like, we're not looking into like the inside of a star like you do, like the crazy shit that you're capable of. I'm just talking about, we see something in a telescope and a star is shining, and that certain star is tens of millions of light years away or hundreds of thousands of light years away. It's just unreal, like how that works. Can you explain it a little bit? Because I'm not doing a good job of it.
No, I think you're doing a fine
I'm
job.
just kidding.
I think maybe the best way to explain it is just that, uh, so we can have a sense of the distance between the Earth and the Sun, right? And no more light years, but the Sun is 8 light minutes ish away. And so what that means is that, this is a simplification, but if the Sun, burned out, we wouldn't see it for 8 minutes, because that's how long it takes for light to get to us, because light travels at a finite speed.
And also, like if we take off from Earth traveling at the speed of light, we're getting to the sun in 8 minutes. Is that right?
Correct. Yeah.
Yes.
Yeah. That's
Okay.
it.
That's insane.
Yeah, but these are light minutes we're talking, not light years. So yeah, absolutely. I mean
So to get to like, I don't know, man. Pick a fucking galaxy for me. I don't know. Or to get to like outside of our galaxy, like the stars outside. How far are those from us? Like give or take, roundabout. You don't have to give me like to the centimeter of light years or whatever.
So I mean, the diameter of our galaxy, with its 100 billion stars, roughly, is 100,000 light years. So it would take light 100,000 years to go from one end to the other. So you just do something at one end of the galaxy, you flash a bulb or something. People at the other end won't see it for 100,000 years.
And that's traveling at the speed of light.
Yeah, because it's light. Yeah.
Like that just broke my brain. It's crazy to think about that.
There are these incredible distances
So,
involved. Yeah.
so like the stars that you're seeing right now, let's say that's one that's on the other end of our galaxy that's 100,000 light years away. That light that's coming and hitting us and where we're looking at
Yeah.
might not even be there right now.
Absolutely. It's from the past. It's
My
from
brain's broken. That's
it's
it.
from our past.
It's my brain is like short circuiting to think about that. Sit there, like that's why like whoever's listening, take a fucking second, pause this video or the audio, and just think about that. How crazy that is. That's why like in the movies like Interstellar and shit, the guy comes back, he's fucking 2 days old, and his like daughter's dead.
Yeah, that's a really good movie, by the way, in terms of the fealty to the science involved. I mean, it's they had some incredible advisors
Yeah.
uh, to deal with some of the science, and it's a solid piece of work.
Chris Nolan loves time and like
Yeah,
bending time and all that kind of shit.
yeah. But that one in particular, the story was good enough that it wasn't kind of overwhelmed by by special effects.
Totally. Yeah, he's a big practical effect guy. If he
Yeah.
could do it practically, he's all about it.
Mm.
Yeah, so the light year thing blows my fucking brain away. I know it's like super like basic shit.
It's not though. I mean, it's something that the more you deal with it, the more you forget about just how big these distances are.
Right. Yeah, I could see that.
You just get kind of used to it, which is unfortunate. Which is
Sure.
unfortunate because I mean, what you need are people to be like, no, let's break it down to the very beginning. Look at like what kind of distances are we talking about?
It's crazy, dude.
Yeah.
It's honestly like I sit there and like randomly during the day and I think about different things. Like I'm like, what the fuck? What do I give a shit about? Like my bullshit fucking thing I'm worried about here. You know
No,
what I'm saying?
I do. But it's the reason people just like to stare out at the night sky if they're in places where they can see the night sky, which is not, most of Manhattan.
No, you maybe get like 1 or 2 stars.
Yeah, yeah, it's sad.
I don't know what I'm. Oh, what the fuck is dark matter? Everyone's talking about dark matter like it's something we can't even see it.
Yeah, yeah. So you're absolutely right. The reason it's called dark matter is because we don't understand it, so we call it dark. It could be any. It could be called George. But I mean,
I like
the
that better actually.
the whole point of dark matter is because it explains something that that we don't understand. The idea came around, I believe in the 30s. This idea that okay, if galaxies have most of their mass in their center, where we see the most light coming out of there, fine. Then we'll say most of the mass is there. Then stars, at the outer edges of the galaxy in the spiral arms, say, of the Milky Way. Well, then we should be able to understand how they travel around this big bulge of mass at the center. And and you can just use Newtonian mechanics. This is like a standard question for first year university physics. And you predict that the further out you get from the center, the slower the orbital velocity is. And you can predict it and draw a nice curve of orbital velocity versus radius. The problem is that for galaxies, they don't do that. Rather, as you go out from some spiral galaxies, as you go away from the center, uh, rather than the orbital velocity dropping with radius, it stays constant. And you don't really understand that. So then you're like, okay, well maybe there's a bunch of matter outside the kind of central bulge that we can't see for whatever reason, and then and that matter extends to the very edges of the galaxy. We can't see it, but it's there. That
Right.
solves the problem. So it starts with you have these observations. You ought to believe your observations. And so then you're like, okay, well maybe our theory is wrong. And so the theory is like, okay, well there's this extra matter that's hanging out, that's making these stars behave in this funny way. And we're
Mhm.
going to call that dark matter. And so in terms of what it is, well, it's dark, so it's not in the form of, stars or planets that we can see. It's not, these clouds of normal matter that could be like, gas or dust or anything like that, because you could at least see them indirectly
Right.
by by
You can
by the
distinguish them. Like,
exactly
right.
from radiation passing through them or whatever. You could distinguish them exactly. And another idea is that maybe there's this antimatter stuff. Maybe that's what's responsible. But there are these kind of gamma rays. Well, if it's antimatter, then you'd expect antimatter and normal matter to collide every once in a while or all the time. But that leaves a characteristic signature in terms of gamma rays that we don't
And we
see.
can pick it up. Right. Okay.
Exactly. You could detect some signature of it. And so then, okay, well, maybe there's these big black holes that are there. But those you can detect indirectly as well, because big black holes bend light. And so you can see you can see things behind big black holes from how they bend the light around them. So
Right.
this is one of the predictions of general relativity, which was kind of famously proven and made, Einstein a star. So I mean, none of that works. And so what are the answers? And the answers have been the same basically for a while. And not, we still don't really know, but the two best candidates are that, maybe it's stuff that we know, but it's kind of small and dense so that we can't see it because our instruments aren't good enough.
Aha. Okay.
So these things are called machos
I like
because
the name.
yeah, it goes for massive compact halo objects. So it's these ideas that they're like our sun, but they're less massive. So they never got a chance to fuse hydrogen to become helium. So they never kind of ignited.
Okay.
So there are all these things just kind of sitting around, and maybe
And it's
that's
extremely dense, and that's why it makes things not orbit as slow as we think it should.
could be. Yeah, it could be. And the other idea is that it's some exotic particles that we don't know.
That we
So
haven't discovered yet.
yeah, yes, that's it. But they have a name. There are these things they're called WIMPs, which are weakly interacting massive particles.
Yo, who came up with these names? Are fucking excellent. Whoever came up with them, the acronyms.
Yeah,
10 out
well,
of 10.
it's because if you don't have, or if you can't prove your theory, you can at least make a good acronym.
Yeah, exactly. Like try and sell it as much as possible, right? Yeah,
Exactly.
it
Yeah,
makes sense. I get it. Like you got to come up with something that's snappy.
that's right. That's right. And so the short answer is no, we don't know what it is.
Fuck, that's
Yeah,
so crazy.
right.
What happened with Pluto? Why did people get so pissed at Pluto and didn't stop making it? Stop calling it the ninth planet.
Well, just I mean,
Too small.
yeah. Well, I mean, I think it was, it became a dwarf planet, right?
What a hater. I think they prefer. I think they prefer midget, don't they? I'm kidding. Joke. That's a joke, guys.
I think it depends on who you ask. Um, no, I don't know. People get pissed about these things because they have these sentimental relationships to them.
That's what I remember. Pluto, man. Pluto
Yeah,
was the fucking ninth planet. It was the tiniest one, but it was still a planet.
yeah, right.
I saw Pluto how like people saw Bumblebee in the Transformers, like he was the smallest one, but he was
Yeah,
the scrappiest one, and that's why people loved him. That's what Pluto was to me. And then they fucking threw him out. Like that's not cool.
no, Bumblebee was my favorite as well.
Right? It's everyone's favorite. I mean, Bumblebee's like the little scrappy guy.
Right.
Okay, so you mentioned black holes. These things are crazy. I mean, like, what do they do? When I picture a black hole, when I think of it, I just see it as it's like when you see a drain
Yeah,
draining.
yeah.
So I feel like it just sucks everything in. Is that like kind, or is it just light it sucks in? Like
No, it'll suck everything in.
so to eat like planets and shit.
Yeah, sure. Um, yeah. I mean, it's really difficult to describe these things because a black hole is kind of by definition, I mean, it's a singularity. So that's just a fancy word, meaning that it's something that is fundamentally kind of outside of our knowledge. I mean, it's like a point.
Right.
It's just a point. The big, the swirliness of the drain, you can think of as just all the stuff that's moving around it and being kind of heated up as it moves around, and so it's maybe emitting light, and
Okay.
that's the swirliness. The black hole itself, you can think of it just like you get a sheet, okay, and you you drop. Well, this is a bad example, I think. You drop a really small heavy thing in the
Uh-huh.
center, all right, a really small heavy thing in the center, and then you send some other balls around it, and
Like
they'll
little marbles, and they go down.
exactly, and they'll start rotating around it, and eventually they'll drop.
So the theory that there's a black hole in the middle of our galaxy of the Milky Way, is that what do you think? What's your take on that shit?
Yeah, so that kind of was reevaluated, or it's being reevaluated. I think that so I have to say that until rather recently, I mean, there's the consensus in the scientific community that yeah, there's a big kind of supermassive black hole, like 4 million solar masses, meaning 4 million times the mass of our sun, um, sitting at the
Those
center of the
numbers are
galaxy.
crazy.
Yeah, they are crazy. But I mean, they come from, we can't see it, obviously, it's a black hole, but we can infer it from the motion of stars in the vicinity of it and say that, okay, well, these things move a certain way because of a big mass, kind of that,
Okay.
that needs to exist, at least according to the way we understand things,
Sure.
to make them move like that. And I mean, that result was given the Nobel Prize in 2020.
I could
And
respect that.
I looked up the citation, and it says for the discovery of a supermassive compact object at the center of our galaxy. Note that it doesn't say black hole, but
Why not?
well, I'm not sure. I have to be honest with you. I'm not sure. A black hole is a compact object, but I'm not sure why it's not explicit in that. But I mean, it could be because I mean, just a few years before, in 2014, there there were these strange kind of these weird things. Like there was this gas cloud that didn't move as expected around the center. So there are all these kind of famous things that move in a nice way that we can track, and it's like, okay, this is all consistent.
And
But now you have this
it fits in the theory and stuff like that, right? Okay.
exactly. But there's this gas cloud now that doesn't move like we expect. Just one thing, but we can see it, and so you can't discount it. You need to explain
Right.
it.
Yeah.
And so the researchers that tried to figure it out said that okay, well maybe, and so you just start throwing things at the wall, being like, well,
Sure.
how can we explain it? So they said that well maybe it's not a black hole, but it's a big mass of dark matter.
Dark
In
matter
essence,
comes again, back
yeah,
again.
right, a big mass of dark matter.
Everything is
Whatever,
wrong. Anything that's wrong, we blame dark matter. Huh? Is that how it goes?
dark matter. It's a we don't know what it is,
Yeah.
but let's say it's there, and they find that um, if the elegant part of having dark matter there is that then, like I was saying before, we need dark matter kind of throughout the edges of from the center going out to the edges to explain what we see at the edges.
Right.
But now, if we have dark matter also at the center, well, then we don't need to have two things. We don't need to have a black hole at the center and dark matter kind of going out to the edges.
Sure.
Instead, it's just all dark matter going out from the center all the way to the edges. And they find that because when you get rid of that problem of having this kind of black hole plus dark matter and just have a dark matter distribution all the way from the center out to the edges, well, then you can explain, you know, the observations better.
So let
Uh,
me ask you, do we run a risk of trying to come up with theories that fit into our already like theories that are working and stuff? Like, are scientists biased in terms of like maybe trying to prove their theory right and being like, being a little bit more subjective?
Scientists are. So ideally, yeah. I mean, you'd hope that all scientists are like, okay, I'm just going to look for the best thing that fits the observations. But yeah, I mean, when we're all humans, when you've invested so much effort and time and your career into one particular theory, you're not going to let go of it very easily, right? You're going to say, well, maybe the observations are wrong. Maybe the instruments aren't picking things up. Maybe it's just something else. Maybe there's something else in your field of view. Maybe my
Yeah.
theory can still be correct.
Listen, I could totally see it. Like a guy wins a Nobel and like he's highly touted, writes some books, ends up on fucking Stephen Colbert or whatever. He gets like the whole, ticker tape parade thing.
Yeah.
And then people start trying to poke holes in his shit. Like I could see him being against that. like trying to fight that for sure, because we
I
are
mean,
human.
exactly. And so, I mean, we don't know. I mean, the question is, I think the community is still, to a large part, okay, it's a black hole and there's this gas cloud is just something weird. But in terms of the problem is that you still need this dark matter, which we don't understand. So if you have just more of it, is that such a big problem? I don't know.
Right. Yeah, and I would think like with the gas cloud that's not acting the way other things act,
Right. Right.
that's got to like jazz people up, no, to like figure out
Totally.
what the fuck it is and stuff. I mean, sure, some people are gonna be pissed, I guess, whatever. Like the black hole guy who copyright wrote the fucking thing, I guess
Right.
he's gonna be pissed. But I mean, at least like this is something new that we can look at and
For,
observe.
for sure. The and then the more you go down these rabbit holes, the kind of you really kind of see the humor that comes out because it's you have these whatever dark matter particles that are clumping together at the center of the galaxy and that solve all the problems. But then the researchers who came up with this, they were like, well, maybe they think that past a certain point, you get enough balls of these they call them darkinos. You get enough you get enough balls of these things together that they may collapse into a black hole.
What the fuck? So enough of them creates a black hole?
That's what they're thinking.
That's
So
so interesting. Wow.
it's really funny how it could come full
Right.
circle, right?
I mean, that kind of makes some logical sense. I mean, what
Yeah.
the fuck do I know? Again, like literally.
No, I don't. No, I don't know. I mean, like I said, you spend enough time studying these things, you can make yourself the world expert on it.
Right. Yeah, I could see that for
Just
sure.
because nobody else knows and nobody else has spent a year, 2 year, 10 years of their time on this.
So that article I sent you from BBC about
Right.
the two scientists have detected two collisions between a neutron star and a black hole in the space of 10 days.
Yeah, that's amazing. That's
I mean, what the fuck is going on?
yeah. Well, I mean, again, I mean, I suspect this is
What's a
just
neutron star?
what's a neutron star. So
Yeah.
so when you have um, a star like our sun, say,
Yeah.
okay, when you get to somewhat heavier than our sun, maybe 20 times the mass of our sun. Um, okay, let me even go further. So the sun works by fusing hydrogen into helium,
Okay.
and that releases energy,
It gives you a
nuclear,
good buzz too.
right? That releases thermonuclear energy, and the reason the sun doesn't just collapse or expand into nothingness is because you have two things that are competing against one another. You have gravity from all the stuff which always wants to go towards the core, so it wants to collapse, and you have this energy which you can think of as, if you want, as like tiny little photons that are blowing against a piece of paper. And so there's this radiation pressure that's going outwards that's keeping the star from collapsing. So those two things are in balance. When you have a somewhat larger star, um, after everything that's fused together to produce energy um, has done its magic, you get from hydrogen all the way to uh, up to nickel. Okay, up to these things that if you fuse them together, you no longer get any energy out.
Okay.
And so what's going to happen then? Well, if you don't have any more blowing on the piece of paper, well, the thing's just going to collapse. So you
Wow.
get collapse, 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 and the exact mechanism of the collapse is not well understood. But we know what happens because that's a supernova, and
Uh-huh.
so,
Okay.
and so we can see these supernova explosions. And so what's happening is that all the stuff is collapsing on itself. The core is shrinking as well through some mechanism that's not super well understood. The core then bounces because you have so much stuff coming on it. I mean, you can picture it. You have this stuff coming on you. The core bounces, sending more material out, and then you have these things called neutrinos coming out from further reactions near the core,
That
which
was my ex-girlfriend's last name.
neutrino, which send the material
Italian girl. I
out.
know. Italians are no good at you. They're not welcome here.
Well, neutrino, is an Italian physicist who came up with the word.
Was it? That's awesome.
And so all this material comes out, and what you're left with, depending on the starting mass, is a neutron star or a black hole.
And a neutron star is extremely dense, right? But it's
Yeah,
smaller than our sun.
A way you could think about it is maybe it's something the size of Manhattan that's, the mass of the sun.
Okay, got it. Yeah, okay. So it's tiny. It's tiny in terms of like celestial objects, I guess,
That's that's right.
but
That's
it's
right.
extremely dense.
Correct.
And a black hole fucking ate two of them in a week, in the span of 10 days.
That's right. That's right. And I mean, I suspect we see it just because we're looking for these things. We have these precise instruments that can detect gravitational waves. So I mean, these are gravitational waves. These are these things that are kind of rippling through the fabric of space. It's like a okay. Let's have this sheet again. All right,
Do it, yeah.
and we'll drop two heavy things in, and as they move together towards the center of your crappy bed, which has a big hole in the middle.
Yeah, yeah, yeah.
As they move together, you can feel kind of the ripples that are coming at the very edges
Hmm.
until they hit each other, and
Okay.
then you get no more ripples
And like
because
even when they hit each other, there's no ripple effect. Like we don't see
you'll
that
see
happening.
that.
Oh,
Yeah,
okay.
you'll see that. That's a part of the gravitational wave signature.
I
Yeah.
see. Okay.
And
That's fucking crazy.
that's how we detected it. And I mean the kind of craziest thing is that you would never have seen these without these gravitational wave detectors because there was no kind of observable signal. Often you'd expect, some sort of big release of energy or
Sure.
something that happens, but there was no kind of signal, anything like that. So then people are like, okay, well, why isn't there any signal except in terms of these gravitational waves? And so maybe the black hole just swallowed the neutron star in like a big bite, like boom, and then nothing else could come out.
So
But
that's the theory explaining why we're not getting any more signals from this neutron star.
yeah, or we didn't see any kind of big when they hit each other or
Right.
when
Right. Okay.
they got close enough together. Why we didn't see anything? You might expect that the black hole, just because of its phenomenal gravity, would tear apart the neutron star, and then the kind of that stuff might funnel in.
Sure. And you'd see it would look different.
Yeah, right. It would look different, and maybe you could pick that up, but we didn't see any of that.
And now we're blaming that it's a black hole that ate it up. No chewing, nothing. Just ate it. Swallow
Yeah,
one shot.
like a Pac-Man kind of thing. Yeah.
Am I crazy to say this? I am. Again, I'm just a fucking dummy. But um, when we can't understand shit in physics and astrophysics, do we just blame dark matter and black holes? Is that like the trump card?
Well, you can blame. We tend to blame things we don't understand. So you could call it dark matter. You can call it a black hole, which is kind of lives in the same kind of world of things that are you know we don't really understand.
Oh, yeah.
Or you can blame dark energy, which is something else as well.
What's dark energy now, dude?
Yeah.
Like
So
force?
yeah, man, you can think of it. It's definitely it's like dark energy is like an anti-gravity kind of. You can think of it like that. So I mean, even in like, and this is pretty late, like in the early kind of 1990s, uh, it was kind of thought that the expansion of the universe, we know that the universe is expanding, but it was thought that maybe gravity, just because we know all the stuff in the universe and we know gravity kind of pulls things together, it's figured that gravity is going to slow the expansion as time went on. Maybe it won't all come back together to a point, but it should slow. But then in 1998, there were these incredible observations of kind of very distant supernovae, which I kind of just mentioned, and that it turned out that a long time ago, the universe was actually expanding more slowly than it is today. So the expansion is not slowing; it's accelerating. The universe is expanding at a faster and faster rate. And so, how do you explain that? And so, literally, the people didn't know what the explanation was, so they gave the solution a name, and it's called dark energy.
That's nuts, bro.
It's like we don't know what it is, so we're going to call it dark energy. And so, what is dark energy? And so, you know, no one really knows. But
Sure.
I mean, just for some ideas, I mean, people are thinking that well, maybe space itself has this property that it's kind of like anti-gravity. And so that as the universe is expanding, there's more and more space that's created, which is making
It
more
go
and more.
faster.
Yeah, exactly, making more and more anti-gravity. It sounds crazy, but you have to come up with crazy ideas.
To explain it.
Yeah, and another idea is from quantum theory. This idea that empty space is not empty at all, but that all these particles can kind of bubble in and out for very short periods of time, but they can come into existence and out of existence and into existence at any moment in time. The problem is that if you assume that in your theory, you get a crazy answer that's wrong by a 1 with 120 zeros, after it. It's because the answer comes out too big, that you get too much of this anti-gravity. And so that doesn't seem to be a right answer, but it's a weird premise to start with anyway.
Sure, yeah.
Or you can say, well, maybe Einstein's theory of gravity is not correct, which is kind of the fallback. Who
Sure.
knows?
Like Einstein didn't know what the fuck he was talking about.
But the problem is that the theory explains so much of what we know that
Right.
giving it up, like we were saying earlier, there's kind of this need to then explain all the other observations in addition to this dark energy.
So we really don't know what the fuck's going on. We can kind of like read some shit and be like, oh yeah, that's a star and it's made of this. It's on our periodic table and stuff, so we can figure it out.
Right.
We don't know what the fuck's going on here, so we're just gonna say it's dark something. Pick a fucking word after dark.
Right.
A noun.
Right. Well, but I mean, the big, and it gets even worse.
I want to hear it.
I mean, based on what we know of our cosmology, we need more. The universe then is composed of about 5% ish of stuff we know, stars, planets, all the stuff that makes our lives interesting or not interesting.
I'm not a big math guy, Anuj, but 5% is a lot less than 100%.
Yeah, man.
Am I right on that?
You're right on that.
Yeah.
So you got 5% of all the stuff that we know and love. 27% dark matter, which is the stuff that we know we need for galaxies, the stars around the galaxies to move in a correct way. But 68% of the majority of the rest of the universe is dark energy.
Bro.
So it's all this stuff we don't understand, right?
I mean, what happens when there's some fucking smart ass kid that comes into your class and is like, what the fuck dark energy is about? And he's trying to like outsmart you, because I'm sure they all try to do that, right? Like they all have their theories and stuff. Like, what do you do? Like, bro, get lost. I'm telling you.
Well, I mean, what you want to say is, well, maybe you need to study this. I mean, maybe you need to come up with some sort of new overarching theory that kind of fills in all these holes. Because, like, I mean, dark energy, it's a clear hole. We don't know the solutions.
The big one, bro, 68%. I mean, come on.
Right. I mean, the idea is that maybe if you give it a name, you can sound smart and sound like you have some sort of solution. But it's literally the name of the lack of a solution.
That's so interesting. I mean, even like you said with black holes, like it's a singularity. Like we don't know what it is. We know it's there, but we don't know exactly,
Yeah.
We don't know exactly what it is. It's fucking crazy to think about.
And maybe it's a big clump of dark matter. I mean,
it's what it sounds. I mean, that's what the theory, like that's what seems like people are pointing that way. I mean, what do I know? It's fucking crazy. But what's dark matter? We don't know either.
No, you're correct. We don't know.
And then what's dark energy? We don't know that either.
No, but it's even harder because it's the stuff that doesn't come from the need for galaxies and stars, but it's just disconnected. It's like the universe is expanding. Why? It is expanding at an accelerating rate. Why?
And the initial theory was it was slowing down.
Well, just the idea is that it should slow down because but there was no proof for that. It was just this
idea. That is fucking crazy. What do you think? Are we in a simulation, or is that just rich people saying because their lives are so great? We're in a simulation.
So this, I have to say that this question is obviously it's more philosophy than physics, but I mean it's the kind of thing that if someone says you're in a simulation, you're like, okay, if this is kind of a simulated world, well then what is the thing? What's the computer made of? What's the thing outside the simulation?
What plane of existence are they on?
Exactly. How does that work? It really sounds like the idea from Indian mythology and from other mythologies of the earth is on the back of a turtle, and what's the turtle on? And it's turtles all the way down. So it's such a bizarre way of thinking about things. I mean, I like I like thought experiments. I like the idea of it. I think the most interesting, at least for me, part of the hypothesis is this idea that just at the very end, where it said that therefore, if we don't think we are currently living in a computer simulation, we are not entitled to believe that we will have descendants who will run lots and lots of simulations of their ancestors. This idea that, if you think that, okay, well, I don't have the computing power to do these kind of simulations, but, in whatever, a
Right.
thousand years, we'll have people around and they will run these simulations. Well, then, if you're thinking like that, well, then you should be in agreement with the idea that maybe you're in one of these
Right
simulations.
now, yeah.
Right, exactly. Um, because I don't really play, I don't really play video games. I'm not into, Second Life avatars or anything like that.
Yeah.
And I'm not really into genealogy or, trying to figure out what my ancestors did in such detail. I wouldn't be running one of these simulations
Right.
if I had the tools. I'm interested to see how people lived in different times and different places. That's cool, but I don't need a full ass simulation to show me that. Just give me like a virtual reality or whatever, something that I can step into,
Hmm.
and I'll be happy with that.
So you talked a little bit about like quantum physics and stuff. That's a whole big thing now too, where like I guess these things come like they become like trendy and stuff, like theories, I guess. They come back in mode
Yeah.
where like there are different dimensions and all that kind of shit. Like to me, that's on I can't even fucking I don't even I can't even begin to understand that shit. Like
Yeah,
are there different dimensions like
you can't picture it. I
right.
mean, I mean, imagine we lived in our universe wasn't three dimensions of space, but it was two dimensions of space. So you were basically like a cartoon on a piece of paper.
Yeah, just flat. Yeah.
Yeah, exactly. And then someone came with their finger and poked through the piece of paper. You would be like, "What is going on?"
Yeah.
You basically see like this part of your world that you can't enter because it's been poked through. But I mean, you would never be able to picture this idea that a finger is coming from another dimension through your world because you don't have the brain power because
Right.
you have a two-dimensional brain.
Do
It's
you
the same
think
idea.
do you think there's any truth there?
Um, well, I mean, it's I guess it's very difficult for me to say. The quantum world is really bizarre. We've been talking about bizarre things for the past hour,
Hell
but
yeah.
the quantum world is even more bizarre because it's a place where things are so small that you can't make any predictions about any one like electron will do at any moment of time. It's not like saying I throw a baseball and I can predict with good accuracy what's going to happen to it.
Mm-hmm.
Rather, you can only do it in terms of statistics. So, I mean, it's like, well, maybe it's here at this point in time, maybe it's here in this point in time with this level of confidence. So, I wouldn't give up anything in the quantum world in terms of different dimensions and stuff. I mean, I'd have to see. I don't recall exactly what in what context it came up, but I mean, the quantum world is sufficiently weird that like dark energy, it could be anything.
Yeah, so it sounds like it's fucking Dark Energy's fucking cousin from fucking Kentucky or whatever, you know?
But on a very small scale, right? I mean,
Right, right. Okay, yeah. Oh my god. My brain broke. So we're not in a simulation. I agree with you. I mean, I don't know what the fuck we're doing.
I mean, it sounds like it's something that's a bit. I mean, it sounds like what people can talk about, with their buddies late at night with too many beers, or
Sure.
not, or maybe in the middle of the afternoon. But I mean, to debate it, we have no way of proving it.
Yeah.
So, is it worth wasting our time on?
That's the thing that I'm saying. Like, yeah, that's why did like these smart people, quote unquote smart people like Musk or whoever, are like they're talking about it, how we're in a like how the fuck do you know? Like, is
Yeah.
there actual tangible, readable evidence that makes does 2 + 2 = 4?
No, no, there's no tangible evidence in any
Yeah,
of
so
that.
fuck off. Let's stop wasting bandwidth on it. You know what I'm saying?
Right, right. I think it's people like to kind of provoke other people and
Yeah, he's
push
a.
their
Yeah, I
buttons.
mean, Musk is a total troll. You're right.
Right.
Well, I said it. You're not right. I said it. Don't want to make fun of Musk. So, can we really mine asteroids? Is that something that Musk and Lex Luthor, Jeff Bezos are looking to do?
Um, I don't know. I think people. I mean, these are again. This is an idea that comes and goes. I mean, in Alien in 1979, that's what they were doing, right? I mean,
Right.
they were coming back from
Also,
having
what's the other one? Armageddon too. They went and mined. They went
right,
and dug a fucking nuclear bomb and shit.
right. But I mean, okay. So what are the difficulties? I mean, it costs a lot of money to send spacecraft up. You don't really know what you're going to be mining. I mean, you have an asteroid. What's it really have? You can maybe make a guess, but who knows?
Right.
And I mean, how are you going to get that out? Get this stuff out? How are you going to bring it back? Do you have an alien with you? I mean, I mean, these are all kind of things that you need to consider. But I mean, okay, what's the payoff then? Maybe you find something. I mean, from some estimates, maybe some asteroids contain as much, say, nickel or iron that the world could use for 1 million years. But I mean, okay, but we have lots of nickel and iron
Sure.
on the planet as well. Is that really something you want to go out in space and get? Okay, what about platinum? Always seems to come up. So what if you find something with a lot of platinum? Great. Um, you bring a lot of something back.
It's gonna dive bomb the price.
Exactly, exactly. I mean, you're gonna always have people that are like, okay, well, it's from space, so I'm going to pay a lot of money. But ultimately,
Okay.
everything's from space. Like everything that we know, it's made from the interiors of stars. Or so, I mean, is it really so special? I don't know.
You're so right. Yeah, you're right, man. It's really interesting, right? Like they like also I feel like just like practically, it's not like going like it's not like the 1800s where you're going out west to go fucking find gold.
Right, right.
That in and of itself was a whole ordeal and looking for oil. Like, how do you land on an asteroid? Like, how do you do all these things?
Yeah,
Uh,
yeah, exactly. I mean, I think the more you look at it, the more people have these elaborate ideas or names for things. It's like, well, this will be phase one where we do this, and phase two will be this, and we'll call it, this. And but these are just it's like these titles of dark energy and dark matter again. They're just names for things that we don't know how to do. So it becomes as elaborate as you want it to be until you start to figure out, well, maybe there's no reason for do this in the first place.
Also, like how to execute it in a way where it makes sense. Like, this is actually a tangible thing to take on.
Yeah, I mean, in the near future, it's not, I can't see it happening.
Right. There was one other thing. Oh, the guy Avi Loeb. What do you think of Avi Loeb? Nice guy. Seemed like a cool dude. Besides like his like nihilistic fucking super cynical fucking way. Like, we're fucked in 100 years, 200 years max.
Yeah.
He seemed like extremely like he was awesome. Like I really enjoyed that pod with him. He mentioned something called a light sail.
Ah, okay. Yeah.
The fuck is that?
Um, from what I understand, it's this idea that you could maybe travel through space just with something very thin, very light, and just use this idea of radiation pressure. Again, this idea of where you think of light as these particles that are like you're blowing on a piece of paper, and that's pushing you around. So you're using things for free, and so you're not using any propulsion except something from the sun or from some other star.
And like, didn't they calculate that you can travel like half the speed of light or some number of the speed of like a speed that we're not fucking we don't know. We've never traveled that fast.
I haven't I haven't looked checked on this lately, but yeah, I mean it seems to be not infeasible, not unfeasible to kind of use this kind of idea to travel around. Yeah, I mean
That's crazy. Like how like we should be honestly the world power should be pouring tens of billions of dollars a year into this shit instead of like another aircraft carrier. I'm not like sure
well,
aircraft carriers are cool as shit. I get it. You know what I'm saying? I love a fighter
yeah,
jet,
yeah,
but let's pour this. Maybe like who knows? You know what I mean? Let's try and figure this fucking out.
yeah. I would agree with you. I mean, there are kind of practical issues of how do you get something so thin and it doesn't rupture, right? Just from idiots kind of touching it.
Right.
But yeah, I mean, I would agree with you. This kind of idea of a solar sail has been around for a while, and it's kind of a again one of these first year problems in that you get in physics that is meant to kind of entice students to study more
Got
physics.
you. I mean, they work, bro. Like I'm a
Yeah,
dummy and I'm all about them. Like this shit's crazy. Like why aren't we trying this?
I you know it. I used to teach first year physics, and the problem that I always had is that it's just so boring. Unless you pull out like really cool examples that are relevant and not examples from 300 years ago, like pendulums and like, come
Right.
on, those are all great. You need to understand them because they're kind of basic things in physics, but they have physics is so cool. There's all this crazy
Sure.
stuff, and that's how you get people to study physics.
So where do we go from here, bro? What's gonna happen?
What's going to happen, period, or
Yeah. What's like the next big theory that's gonna come out, like that you've heard?
Oh man. Um, the next big theory that I'm hoping is really kind of we hit the nail on the head is that this idea of just dark energy needs to be kind of reconciled with something that we can understand. And it really seems that just because of its prominence in our universe, based on what we know right now of the cosmology, like we were saying, the 68% number, it's it's a big problem, and it seems like we're just kind of screwing around in a corner of a space, and our eyes really aren't open to what else could be out there.
Right,
That
like we're in this big room and we're like turned around in the corner looking at this one thing, but there's so much other shit behind us.
exactly. And you're looking at how this one thing is reacting, and you're creating all these names for things that are pushing it around, when it's really just a big dragon behind us, kind of breathing on it, or
Yeah,
or, or something that we would never have thought of.
that's so crazy to me because again, I don't really believe in God, but like the closest thing you're gonna get to it, or some kind of fucking whatever that we don't understand,
Yeah.
that faith comes into play, is right here. So if I'm like a fucking priest or whatever, whoever does the community, like the PR stuff for churches and fucking
Right.
mosques and stuff,
Right.
I'm digging into this shit. Like that's
Yeah.
God right there, guys. You can't
Exactly.
see it, but like the faith you have, like you know what I mean. That's an easy
Yeah.
sell. I feel like,
No, I think that's it.
and like I'm a believer of most likely once our lights are out, our lights are out. Like
Yeah.
individual, like human wise, right? Like I really don't think there's some fucking cloud heaven that we go to and hang out and drink fucking mai tais all day. You know,
Right.
unfortunately,
Yeah, unfortunately. I mean, yeah. I mean, as you were saying, and when you have an absence of science, that puts a foothold for faith to step in.
yeah,
And a lot of these things, just because they speak to the absence of knowledge, you just have to keep going, keep proceeding with, trying to find things that you do understand, but you do that out of faith that they'll lead you to a place that you do understand.
right, yeah, I'm with you. I mean, very well said. That's, I mean, dark energy 68%, then 27% is dark matter.
Yeah, yeah,
That's nuts.
yeah.
I'm not a scientist. I'm not even
No,
a fucking poet. That's just fucking crazy.
no. You ask any physicist, and you pull those numbers out, and they will start to he hem and haw, because it really speaks to our need for a better theory, I think.
Right. Do they get like they start sweating and freaking out? Like, no, but you know,
They would. What they'll do is point out that we have these observations, and the model that we have based on the standard Big Bang is reproduced in this way, and this is what we need. But that's not really an answer.
right.
That's more a description of the problem, I think.
So the Big Bang Theory, and we'll end on this one. What the fuck? Give me a layman's term, layman's explanation on it.
Um. Okay.
I mean, I
So
kind of do understand it, but I'm just whoever's listening.
yeah, yeah, yeah. So about 14 billion years ago, um, everything that we know
Can I
came
stop?
into
How do we
yeah.
know 14 billion years ago?
It comes again from our cosmological observations.
Okay.
It, it's
So, but
it's
it's like it's observable. It's like compute. You know, you could check it with a math equation that I don't even begin to
it,
understand.
it, it's kind of linked to the same way that we understand to the 68%, 27% numbers. They all come from the same kind of model. They're all internally consistent. And that when you have consistency, that should make you believe it. The
Right.
problem is when you have consistency with something that maybe you don't really understand.
Yeah. Like that's crazy. So like we're building our thought process on something that we might be totally off on.
Maybe, yeah.
Fuck
Maybe,
me.
yeah.
What the fuck, bro? Okay.
So in terms of the observations that really are behind all, like why do we have these numbers, right? And so the idea is that, so you have the Big Bang about 14 billion years ago. That's when the universe was formed. Okay, everything that we know came out of here, and so then you have this kind of this stuff, right? And then you have where should we go? So you have this kind of hot kind of plasma of radiation,
Uh-huh.
of like protons and of electrons, and they're all kind of interacting with one another. But then at some point, as the universe is expanding, because we know it's expanding, and but that's observational, we can observe that it cools off enough that the electrons combine with protons to make a neutral hydrogen atom. So this is chemistry. But now this thing is neutral. It's no longer charged. So they don't interact with the radiation in the same way. So the radiation then is free to kind of expand through all space. Before it was kind of tightly linked with the distribution of protons and electrons because they're all kind of interacting with one another. Because they're all, well, just because the radiation likes to interact with charged particles like electrons and free protons in a very particular way. But once these things combine, meaning the protons and electrons combine to be neutral, well, now the radiation doesn't have anybody to talk to, so it kind
Sure.
of does it does its own thing. But the radiation, so this was called the recombination era because that's when the protons and electrons combined. And so, but these photons that are now free to do their own thing, they carry kind of a memory of what the universe looked like when that combination happened. And so, meaning that if at the point where they were decoupled from the protons and electrons, a photon, say, was in a slightly denser portion of space, meaning more protons, more electrons, well, then it had to spend some of its energy, say, against the gravity of the denser region to move away from it.
Got it.
And if at that time it was in a slightly um, less dense portion of space, well, then it lost less energy leaving that kind of region than the other photons. And so the best part is that these kind of fluctuations in the energy of the photons is something we can see.
Okay.
As the universe expanded, um, well, these kind of signatures of the photons were frozen in, and we see that as a kind of a map of the universe
Mm-hmm.
where some regions are slightly hotter than other regions, but just slightly. And
Sure.
that all goes back to this era, which is when the universe was about 400,000 years old. Say,
Baby.
14, yeah, maybe 14 billion now, but this is reaching back to 400,000 years old, and we can see that. And the
Holy
question is,
shit.
yeah. So the question is, why can we understand in some detail these temperature differences between the region? And it's the Big Bang model in detail that takes you there. And as parameters of the Big Bang model are things like how fast is the universe expanding, which is where the dark energy comes in.
Because it's expanding faster than it was when it first started.
Correct, correct. And so all of these things come in as ways to understand these observations. And this is what I just described to you is called the cosmic microwave background. And it's these radiation, these photons that came from when the universe was a baby.
Mm-hmm.
And this is the ultimate kind of proof, the ultimate proof by consensus nowadays of the Big Bang model, because we can understand all these differences in temperature.
Right. How is a galaxy formed?
Um,
Is that like a fucking big one?
yeah, I mean, this again happened.
Or is a galaxy just like just a cluster of stars that were like, this is a galaxy now?
Well, I mean, I guess the idea is that it was a big bunch of gas and dust that kind of collapsed, and then regions of it collapsed separately to form all the stars.
Okay. I guess what I'm trying to ask is like, how do we say like, okay, this is Milky Way, this is Andromeda or whatever, pick another fucking galaxy. Like,
Hmm.
how do we differentiate them? Because of the black holes at the center?
They look different.
Okay.
Um, some of them have spiral arms like ours do, but
Mm-hmm.
but but others have, say, well, they don't have any arms, or they're just kind of big balls rather than discs. So I
Okay.
mean, so these things can form in different ways.
Bro, my brain is fucking mush. It's incredible that you retained all this and you know this shit.
It's something that's kind of sufficiently interesting that once you hear it once, you're like, okay, well, this is. I need to go down a rabbit hole for a couple days to try
I
to figure.
mean, forget it. I'm not gonna leave my house. I'm gonna be reading and googling about fucking dark energy for the next
Yeah,
2 days,
right.
and it's your
Yes.
fault.
Yeah, good.
So thank you for that.
You're welcome.
I mean, anything else you want to talk about? It's all. I mean, it's all you. We've been going for over an hour, so.
Uh, I guess I can't think of anything right now. I do find it really interesting though, just to break things down and to have like a real conversation with just about these kind of big concepts that even if you've studied it, you don't really have such a good handle on it. It's I think
That's
it
intense, right? Yeah, and you sit there and you actually point that out and think about that. I'm sure that's not it's pretty trippy.
Yeah, well, it exposes kind of gaps in 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 things that you've taken for granted. Like, like we were talking about with light years. I mean, it's just things you take for granted. Like, this is this many light years away. This is this many light years away. But when you think about it, it's like, well, what are we actually talking about?
Right.
These incredibly huge distances.
Like, have we ever traveled by the speed of light? No. We've never
Yeah,
created something that can go that fast. So, and this
exa-
take and to go from one end of our galaxy to the other, and it will take 100,000 years
yeah,
traveling at that speed that we've never gone before
that's right.
to get there.
Yeah,
I mean, that by itself should the fact that that's a true fact, we should put like $40 billion a year into in terms of like research money from like the United States government. It's fucking crazy, bro. We don't
that would,
need more nuclear weapons, bro. We're good. We know how to do it and we're good at it.
yeah,
Let's pause that. Can we pause that? And then like
yes,
do this?
yes. No, you're preaching to the choir here. Yeah.
Anuj, man, it's been a fucking pleasure, man. I really appreciate the time.
No, the pleasure has been mine.
I mean, let's do this again. If something else pops off or
Yeah,
whatever, definitely stay in touch.
yeah. Do some reading on dark energy. We can
Forget it, bro. I already know I'm gonna be in a fucking rabbit hole. I know it. All right. That's dirtbag history. Thanks, guys.
All
Anuj,
right.
thanks again, man.